everyone, welcome back. What we're going to do now is just do a quick review of what we've been talking about today with regard to how we can use the SEMDistFlow-R package in your own analyses. And I'll also give you some links to other resources that can help when you go to apply the SEMDistFlow-R package to your own data. The first thing we did today is show how to use our SEMDistFlow-R package to create semantic distances in a text sample. We first took a text, or a transcribed speech sample, lemmatized it, and then removed words with low content, like words like the, and, of. And then we computed word-by-word taxonomic and thematic semantic distances in every bigram, or every pair of words. What I'm showing here is a screenshot of part of a data frame when we are looking at just a small text from my favorite movie, Harold and Maude. And what we see here is a cleaned text. So some of the words that have low content have been removed. And what we see in the SD15 underscore cos_rev0 score column is our transformed cosine values in the range of 0 to +2, where low values closer to 0 represent words that are more taxonomically similar, and words with greater values are more taxonomically distant. And in Gloca underscore cos_rev0 score, that column is showing us the thematic cosine distance values. And so what we can do in more advanced analyses is take those values in SD15 and Gloca cos_rev0 score columns to try to do things like compare authors' semantic flows to each other, or relate those values to neuropsychological measures, or do some more advanced analyses. In the second tutorial, we learned how to apply these semantic distance values to many different types of analyses. For example, we saw how we could compare one author's writing to another's to ask questions like, are children's books lower in semantic flow than young adult books, or classic literature like Jane Eyre, Pride and Prejudice, or the works of William Shakespeare? We also saw that we could relate semantic distance to neuropsychological measures. We looked at an example from the Large Aphasia Bank database, where we saw that individuals with aphasia on average showed lower semantic distance values than healthy age-matched controls, showing us that semantic flow is capturing something about the semantic impairment in individuals with aphasia. We also looked at some more advanced analyses, like time series analyses. We can look at these semantic distance values and see how they change over time in a particular text. And there are lots of different kinds of time series analyses that we can do, and I'll give a list of some of those time series analyses in the resources at the end. But we can do things like dynamic causal modeling to try to see if a particular change in one time series predicts a change in another time series. We can relate the variability in time series to neuropsychological measures or other cognitive measures, and so on. We also talked about network analyses. This is an example from a paper where investigators were looking at differences in semantic networks in individuals with schizophrenia, individuals undergoing mania, and control individuals. And we can do very similar kinds of analyses in semantic flow. On this slide, I've listed some additional resources that might help you as you try to apply semantic distance analyses to your own research. The first paper by Jurafsky and Martin in 2021 is a great book chapter that gives an overview of vector semantics and embeddings. So if you want to understand more about where these vectors come from, that's a really great resource. You can also go to the 2010 neuroimage paper by Stefan et al. For an overview of dynamic causal modeling. That paper is really applying DCM to neuroanalyses, so fMRI analyses, EEG, MEG type analyses, but the same kinds of principles can work in time series data in bigram semantic distances like we've shown here. The remaining resources are specific to this package. So this GitHub link where you downloaded the package from has some vignettes that go through step-by-step guides of how to use the package and some example analyses. The Riley et al. 2022 paper, which is currently under review but is available at SciArchive, gives much more description than we've talked about today for the SEMDIST flow package. So you can go there to check out some additional details and any questions that you may have. And then the Litovsky et al. Paper 2022 from just a few months ago, published in Neuropsychologia, is the first paper that we've published using the SEMDIST flow package. And this is the paper where we examine semantic flow in individuals with aphasia versus controls. And so this is a simpler analysis for SEMDIST flow, but is a really great first step to try to see what kinds of things we can do with these kinds of analyses. Thanks so much. My email address is at the bottom of this slide. Feel free to reach out to me if you have any questions. Thanks for joining.